Imagine, if you will, a universe so vast that it stretches beyond comprehension, where stars are born in nebulae, where galaxies collide, and where the very fabric of space-time itself is ripe for discovery. And yet, in the darkest corners of this vastness, there exists an anomaly, a strange and beautiful tear in the cosmic fabric. It is a wormhole, a bridge, a tunnel, a passage not just through space but, potentially, through time itself. A doorway that could connect two distant points in space-time, not through light years of travel, but with a single step. And within it lies a question as old as human curiosity. Can we truly travel through time? Wormholes, while often relegated to the realm of science fiction, are rooted in the very equations that define our universe. And as improbable as they seem, they may be the key to unlocking a deeper understanding of time, space, and the mysteries that lie beyond. The idea of stepping into the past or rushing forward into the future becomes a tantalizing possibility, a dream within reach. But can we cross this threshold? And if we do, what waits for us on the other side? At the heart of a wormhole is something extraordinary, a bending, a warping of the very fabric of space-time itself. According to Einstein's theory of general relativity, space and time are not separate entities, but one unified structure. This means that massive objects, planets, stars, black holes, create dents in the fabric of space-time, much like a heavy ball placed on a stretched sheet. The greater the mass, the more profound the distortion. And in theory, if you could manipulate this fabric in just the right way, you could create a shortcut, a wormhole, that connects two distant regions of space and time. Now, imagine that space-time is a fabric, and at one point, it becomes folded. This fold, this tunnel, is the wormhole. It's as if the universe is offering us a secret path, bypassing the normal flow of time and space. You see, a wormhole isn't just about traversing distance. If we could enter one, we might be able to move between not only different locations in space, but also different moments in time. Think of it this way: space is like a vast, uncharted map. If you could fold it, just so, you would have a direct line from one point to another. No detours, no delays. And because space and time are interwoven, this could extend to moments in history, not just locations. This is the fundamental idea of a wormhole, a bridge not only through the cosmos, but potentially through time. But there is a more accessible possibility that comes with the idea of wormholes, a form of time travel that we might already be able to achieve in principle. For we already know that time does not pass at the same rate for everyone. As strange as it may sound, time is relative. The faster you move through space, the slower time moves for you relative to those around you. It's a phenomenon predicted by Einstein's special theory of relativity, a concept we now know as time dilation. Imagine you are in a spacecraft traveling close to the speed of light. The faster you move, the more time slows for you. In the span of what feels like days, the universe outside could age by decades, or even centuries. This is not science fiction, it's a scientific fact. The faster you travel, the more you can jump forward in time. This, in a sense, is time travel, but only forward. Thus, in a way, space travel at near-light speeds can be a one-way journey into the future. But this is just one side of the coin. The real mystery lies not in racing ahead, but in turning back. Can a wormhole allow us to travel backward? Could we venture into the past and change the course of history? Time travel into the past, while alluring, is fraught with paradoxes. impossibilities that defy the laws of logic. The grandfather paradox is perhaps the most famous. Imagine, for a moment, that you could travel back to the past and stop a pivotal event, say, preventing your grandparents from meeting. If you succeed, you would never have been born. But if you were never born, how could you have traveled back in time to prevent that event in the first place? This paradox, like many others, suggests that time may be far more resistant to change than we realize. It raises the possibility that the timeline, the flow of events, is not something we can easily alter. Perhaps the very act of time travel into the past would be impossible because the universe has a built-in mechanism to resist paradoxes. What if, in the grand scheme of things, certain events must always happen regardless of our intervention? Perhaps in this scenario, the universe would correct itself, ensuring that the past remains fixed no matter how much we might wish to change it. The nature of time, after all, might be such that we cannot escape the constraints it imposes upon us. However, some theorists have proposed intriguing solutions to these paradoxes. One idea suggests that the universe itself may be able to self-correct. In this view, no matter what you attempt in the past, the universe will find a way to restore balance, ensuring that the timeline remains consistent. Perhaps we are destined to live in a universe that prevents contradictions from emerging, a universe where time flows in such a way that no paradox can ever arise. Another theory is even more captivating, one that suggests that any attempt to change the past creates an entirely new branch in the timeline. Instead of erasing or altering the original reality, you create a parallel universe, one where events unfold differently. In this model, time travel doesn't disrupt the original sequence of events. Instead, it spawns a new reality, a parallel timeline where things may be different, but the original path remains untouched. While these theories are fascinating, the mechanics of wormholes themselves are still purely theoretical. For a wormhole to exist, it would require what scientists call exotic matter, matter with negative energy, something we have yet to discover or fully understand. This exotic matter would be necessary to keep the wormhole stable and open long enough for us to pass through. But even if we could create such a passage, we must ask, could we survive the journey? The intense gravitational forces at a wormhole's event horizon would distort time and space to such extremes that anything passing through would be torn apart. The immense tidal forces could stretch and compress matter beyond recognition, an effect known as spaghettification. Could humanity withstand such a passage? Could a ship and its crew endure the bending of space-time long enough to reach the other side? Wormholes, like so many of the universe's most profound mysteries, provoke more questions than answers. They challenge our understanding of physics, space, and time itself. But perhaps in the search for answers, we begin to see that time is not just a measurement. It is a landscape, a fabric, a place to explore. If wormholes do exist, they may offer us not just a way to travel across the universe, but a chance to glimpse into the infinite potential of time itself. Perhaps one day, we will cross through the doorway of time, our greatest adventure yet, beyond the reach of the stars, into the very heart of the universe's deepest secrets.